All right, here we go. Graphing linear inequalities. All right, so we're going to graph, but we're graphing inequalities this time. And it's not just along the horizontal this time, okay? Remember that? You put the open circle, put an arrow this way and all that kind of stuff, right? This is a little bit different, but very, very close to just, quote, normal graphing, if you want to call it normal, but you know what I mean. The graphing that you're used to. All right, so all of these say to graph. I probably won't write that down every single time. And here's what you're going to do. This is part A, for example 1, and you're going to graph x is greater than 3. Now, we're not just doing this along a horizontal line. This is x and y axis, right? So what if, it doesn't say it, but what if it just said graph x equals 3 with a x and y axis? Let's make this a little bit smaller so I can fit it on here. What if it just said x equals 3? What kind of line is x equals 3 on an x and y coordinate? Well, it's solid, but it's going to be a vertical line. It's going to be a vertical line. All right? All right, so if it just said x equals 3, you'd put a point at 3, and then you would do this. If it said this. Don't write that part down right there, okay, because you're just going to have to erase it. All right, so that's what x equals 3 would look like. What does it mean to be x greater than 3? Well, what we're going to do, now, it doesn't say x is greater than or equal to 3, does it? It just says find all the x's that are greater than 3. So what we're going to do, it does not include 3. So what we're going to do is put a dotted line along that line that I would have done, okay? So that's a dotted line. Now, that really doesn't show you anything. The dotted line means we just don't include 3. So we got to figure out what are all the numbers that are greater than 3. Now the y could be anything, right? But the x's have to be greater than 3. So anything over here, anything in this area, right? That's greater than 3. That's greater than 3. Would you agree? And it doesn't matter what the y is. The y could be anything. So what we're going to do is we're going to shade. So that means that any points on that side of that dotted line works for this. All right? So for instance, I said there's 3, like 4, 1. Okay? 4, 1 works, doesn't it? Why? Because the x is greater than 3. I don't care what the y is. That's why it's shaded all the way up to the top and bottom. It just keeps on going. All right? It doesn't just stop where the graph stops. It keeps on going. And it keeps on going in that direction as well. Everybody good with that? Yeah. Did we do this last year? Yeah, that's what I thought. I told you at the beginning you're going to do a lot of repeating of your Algebra 2 stuff. At least at the beginning of this class anyway. First chapter. All right, let's do another one. X minus 2y minus 5 is less than or equal to 0. All right, in order to graph this, what would you do? I mean, there's a couple options you have, but what would you do? Say what? Yeah, I would put it in y-intercept form or slope-intercept form, okay? So y equals mx plus b, that's what I would do. So let's do this. Let's keep the 2y, negative 2y over here. Let's move the x and the 5 over to the other side so it still stays less than because I'm going to subtract an x and I'm going to add a 5. Everybody see what I just did? Divide by negative 2. Divide by negative. So I got to flip it, right? So change the direction of the inequality because I divided by a negative. What's this going to give you? 1/2 x positive minus what? 5 over 2? What's 5 over 2? Can you do that in your head? 2.5. I just wrote 2.5 just because it's a little easier to graph when you're thinking 2.5 instead of 5 over 2. Right? Normally you wouldn't really have to change that into a mixed number, but it just definitely makes it easier to graph. All right, so let's see what that looks like. Now this is greater than or equal to. So we had the dotted line before. Why did we do a dotted line? Was it just because it was an inequality? Well, it was an inequality, but it was not or equal to, right? So if it's just less than or greater than, you do a dotted line. Everybody hear me? Because you wouldn't believe, I mean, last year, so many people got the problem wrong because they put a dotted line instead of solid, or they put a solid line instead of dotted, right? And you will get this problem wrong if you don't put the right kind of line. So how do I know what kind of line this is going to be? How do I know if it's going to be solid or dotted? It's or equal to. Very good. Okay, it's or equal to. That means it's going to be what kind of a line? A solid line. So really, at first, I'm just graphing this like a normal graph with a solid line. Okay, so -2.5. So I go 1, 2.5. That's my y-intercept. The slope is 1.5. So I go up 1 over 2. See how close these are together? I kind of like to keep going a couple times just to, make sure my line is nice and straight. So I'm going to go up 1 over 2 here. You could go down 1 and to the left 2. See how it all matches up? That's pretty good. So I'll just connect them. I like to go a little bit off the graph and not just stay within the graph area, just to show that it just keeps on going. Does that make sense? All right. Now, am I done? No, because it says everything that's greater than. Now, this is a little different. On the x, it was kind of easy. Everything that was greater than was to your right, wasn't it? Then everything less than would have been to your left. What about this one? Do I shade above or do I shade below? Above. Let's see by putting some numbers in where we shade. So here's what I'm going to do, because sometimes it can get a little confusing, you forget or whatever, but here's a surefire method in order to see where we shade. So let's pick an easy point, either below or above. What do you think would be the easiest point to choose? 0, 0, absolutely, okay? So let's choose that point right there. All right? And let's put it in. So let's choose 0, 0. That means if this works, then I shade above. If it doesn't work, then I shade what? Below. So let's pick 0, 0. So we could, what the easiest one, it would be easier just putting it into the original, wouldn't you think? Okay, then putting it, because you got fractions here and stuff. All right, so let's put it in here. So I got 0 minus what? 2 times 0 is 0 minus 5. Is that less than or equal to 0? Is -5 less than or equal to 0? Yes, it is. So that point satisfies this inequality. That's how we say it, okay? It satisfies it, makes it work. Got it? So that means if 0, 0 works, then what about like any number here? What about that number? Will that work? Yeah. Will that number work? Yeah. What about this number right here? This point right here? No, it won't work. So where are we shading? Above, okay? And just kind of, you don't have to like fill in every single gap, but just get the idea of where we're shading. That's good enough. All right, so any point where I've shaded, if I put it into this inequality, it will make it work. All right, it will make the left side less than or equal to 0. But if I pick a point anywhere here, it's going to make it not work. Let's just try one just for fun. What do you think an easy one would be? Maybe like this one, or you can do that one too. Let's do this one. 1, 2, 3, 4. So that would be what? 0, 4. Let's try 0, 4. And let's see if that works. Okay? So x is 0 minus 2 times 4, which is what? 8. Oops, did I do that right? Oh, 0, -4. My bad. Whew. Because 0, 4 would work, wouldn't it? All right. So if that's a -4, what's that? That's a plus 8. There we go. Is that less than or equal to 0? It's not, because 8 minus 5 is what? 3. Is 3 less than or equal to 0? No, it's not. So do I pick that point right here? No, I can't. So that's why it's not shaded. Everybody good? All right. When's this over? Quarter of? All right. Let me try to go quick here. We don't have that much more to do. What if you had What if you had a absolute value? So y is greater than absolute value of x minus 2. Come on. Now, it says greater than. It doesn't say or equal to. So what kind of lines are we going to have here? Dotted lines. Right? What does that minus 2 do? Does this shift it down? It shifts it to the right 2 places. Very good. So we're going to start here, aren't we? And then the slope is just 1, so we're going to go here, here, here. And you could use these as your dots, okay? That's your dotted line. Everybody see that? There, 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 there. So there's your dotted line, but we don't just leave it there. This says it's what? Greater than 0. So where do you think the greater than is? Well, let's pick a number. Let's pick a super easy number. What's an easy number? 0, 0. Let's put it in here. 0, and let's see, put a question mark here. Let's see if this is true. Absolute value of 0 minus 2. That's 0. That's greater than, what's that? That's 2, isn't it? Positive 2. Is 0 greater than 2? Is it? 0 is bigger than 2? Okay. So does this point 0, 0 work? No. So I don't shade there. Where am I shading? I'm shading everything above or inside that absolute value, that V looking thing. So that's what we're shading. And that's your answer. Okay? One more. Do we have time? 2 minutes? Maybe. All right. Here's compound inequality. So -1 less than x plus y less than or equal to 3. What can we do with this? Well, let's split it up into 2 different inequalities. All right, so let's go -1 is less than x plus y, and we could say x plus y is what? Less than or equal to 3. So let's do this. Let's get y by itself. So that means y, put the negative x over here. Now, if I put the y on the left, what's this going to be? It's going to be greater than. I'm running out of time, so you just have to figure this out. So y is less than or equal to -x plus 3. And then we're going to graph both of those. Now, this one, we'll do that one first. This plus 3 one. So the y-intercept is 3, 1, 2, 3. The slope is -1. Let's do this like this. It's greater, it's a solid line. Don't pack up, I'm not finished. I'm not finished. Just hang on. Bell's going to ring in a second, but just hang on. Come on. All right, and let's do this one right here. So this is going to be a dotted line, isn't it? So -1 right here is the y-intercept, and the slope is -1 over 1, like this, like this. Okay, there's your dotted line, right, like this. Now, where do we shade? Well, let's pick a number. Let's put a 0. Go 0, 0. All right, so 0 plus 0 is 0. Is 0 greater than -1? Yes. Is 0 less than or equal to 3? Yes. So where are we shading? We're shading in between those two. And there you go. All right, so it's 9 to 20. Homework is section 1-8. It's page 55. And it's 9 to 20. Now you can go.